Hey everyone, Mr. Hauk here. In this video, we're going to look at the 7.6 notes, which are on the angle sum identities. Very similar to the last set of video notes that I made for 7.5, I encourage you to go through math with CalcMedic's exploration activity on these first two pages. But for the sake of the video length and time, I'm going to jump straight to the important stuff. So the idea behind this set of notes is on our unit circle, we have certain angles, right? We have pi over 6, pi over 3, pi over 4. But there's lots of angles on the unit circle that we don't have written down, right? Like, for example, what if I wanted you to calculate the cosine of 7 pi over 12 or something like that, okay? Well, it turns out if we can use common angles from the unit circle and add or subtract them together and get new angles, then we can use formulas to calculate the sines and cosines of these new angles that were found by adding or subtracting common angles from the unit circle. Okay, so the way that I'm going to format this, I'm going to go ahead and give you some formulas, some identities that you need to memorize. I'm going to talk about how to use those identities, and then we're going to try some problems together. Okay, so these are called the sum and difference identities and the double angle identities, these ones that we're going to work with. So we're going to start with the sum and difference identities first. All right. Plug in the Apple Pencil. All right, here we go. So we're starting with the sum and difference identities. All right, so let's write them down first. They might look a little intimidating at first, but we'll talk about how to use them. So let's say I wanted to calculate the sine of two different angles, alpha and beta, added or subtracted together. Okay, so I want to calculate the sine of two different angles added or subtracted together. Well, the way that we do this is we would do the sine of the first angle, sine of alpha, times the cosine of the second angle, cosine of beta, plus or minus whichever one you're doing, the sine of the second angle, sine of beta, times the cosine of the first angle, cosine of alpha. Okay? So, sine of alpha times cosine of beta, plus or minus whichever operation you're using, sine of beta times cosine of alpha. Let's say we wanted to do cosine of two angles added or subtracted together. Well, cosine's formula looks different. You need to be a little bit careful. You don't want to get them mixed up with each other. The cosine of two angles, alpha and beta, either added or subtracted, is going to be cosine of the first angle, alpha, times cosine of the second angle, beta, and then we're going to switch the sign. If you were doing cosine of two angles added together, you would use the subtraction sign here. If you're doing cosine of two angles subtracted from each other, you would use an addition sign here. Okay, then we're going to have sine of alpha times sine of beta. All right, those are called the sum and difference identities. We also have what are called the double angle identities. Right? So the double angle identities, here's how these work. First one we're going to look at is sine. If I wanted to calculate the sine of 2 times an angle alpha, it would be 2 times the sine of alpha times the cosine of alpha. Okay. Cosine's double angle identities, there's actually 3 of them. You can pick which of the 3 you want to use, but there's 3 of them. All right, so the first one, if I do cosine of 2 times an angle alpha, I could calculate it as cosine squared of alpha minus sine squared of alpha. Or I could calculate it as 2 cosine squared of alpha minus 1 or I could even calculate it as 1 minus 2 sine squared of alpha. All right? So these are called the sum and difference identities and the double angle identities. And the reason we want them, again, is because we might have angles that we're interested in that are not on the unit circle, but we can use angles on the unit circle to either add or subtract to give us different angles. Okay? So let's talk about how to use these, because they're really not that hard to use. So let's start with number 1 here. Now notice that on Math Calcmetics, check your understanding, they're using degrees for 1 and 2. We don't really use degrees in here. We'll do degrees for the first one, but then we'll convert, for number 2, we'll convert it to radians and work in radians instead. All right, so number 1, find an exact value, keyword is exact value, for the sine of 75 degrees. That means we can't just plug sine of 75 degrees into a calculator and get a decimal. We want an exact value. So sine of 75 degrees. Well, the problem we run into is that 75 degrees is not on the unit circle. What is on the unit circle, however, is 30 degrees and 45 degrees. 30 degrees plus 45 degrees would be 75 degrees. So we're going to take the 75 degrees and we're going to split it using 30 degrees plus 45 degrees. So we're taking an unknown angle, we don't know the exact sine value of it, and we're decomposing it into 2 known angles through addition. The first angle we're going to call alpha, so 30 degrees is going to be alpha. The second angle we're going to call beta, so 45 degrees is beta. And now all we have to do is follow the formula that we wrote down above. Sine of alpha plus beta is going to be sine of alpha times cosine of beta plus sine of beta times cosine of alpha. All right, so sine of alpha, sine of 30 degrees, times cosine of beta, cosine of 45 degrees, plus sine of beta, sine of 45 degrees, times cosine of alpha, cosine of 30 degrees. Okay, now we use our unit circle to get these values. Sine of 30 degrees. Well, we should have our unit circle memorized, but sine of 30 degrees, that's 1/2. Right there. Cosine of 45 degrees, square root 2 over 2. Plus sine of 45 degrees, also square root 2 over 2. Times cosine of 30 degrees, which is square root of 3 over 2. Now it's simply an algebra problem. We're multiplying these together and then adding. So when you multiply fractions, remember that you multiply the tops together and then you multiply the bottoms together. So 1 times square root of 2, that's square root of 2. 2 times 2, that's 4. Plus, then over here, square root of 2 times square root of 3. If you're multiplying 2 square roots together, you can put them under 1 square root. So this would be square root of 6. And then 2 times 2 on the bottom is 4. And you can leave it like that technically if you wanted to, but notice that they both have the same denominator of 4, so you can combine these into a single fraction. Square root of 2 plus square root of 6 all over 4. And by the way, square root of 2 plus square root of 6 is not square root of 8. You cannot add or subtract square roots together unless they have the exact same number under the square root. All right. Now, let's do this again, but this time we're going to do a cosine problem instead of a sine problem. And let's get rid of this 255 degrees. Let's use radians instead. So 255 degrees. If you to convert it to a radian, you would multiply by pi over 180. 255 over 180 is 17 over 12, so this is 17 pi over 12. Okay, so we're going to calculate the cosine of 17 pi over 12. Now, one thing you're going to notice a lot of, by the way, when you're doing sum and difference problems with sine and cosine, a lot of the times the denominator is going to be 12. So one thing I did on my unit circle is I converted all the radians to have denominators of 12. So like pi over 6 is 2 pi over 12, pi over 4 is 3 pi over 12, pi over 3 is 4 pi over 12. So if you want to, you can pause the video, you can copy down all my radians with denominators of 12. There's all those in the first two quadrants. And then here's the ones for the second two quadrants. So the goal is, we need, 17 pi over 12 is not one of our common unit circle angles. We need to find two angles that either add up to 17 pi over 12 or subtract to 17 pi over 12. Well, we already did an addition problem for number 1, so let's do a subtraction problem. Let's do a difference problem for this one. So let's find two angles that subtract and give us 17 pi over 12. And the one that stands out to me is going to be 20 pi over 12 minus 3 pi over 12. So 17 pi over 12 is the same thing as 20 pi over 12 minus 3 pi over 12. And that 20 pi over 12, that 20 pi over 12 is 5 pi over 3. And that 3 pi over 12 is pi over 4. Okay, so our alpha is 5 pi over 3, our beta is pi over 4. Now we simply follow the formula. This is a cosine subtraction. So cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Remember, for cosine, if you're doing a cosine subtraction, we actually use a plus sign when we expand it like that. Okay, so this is going to be cosine of 5 pi over 3 times cosine of pi over 4. We're using a minus sign here. This is a difference formula, so we have plus sine of 5 pi over 3 sine of pi over 4. All right. The cosine of 5 pi over 3, that's going to be 1/2. Cosine of pi over 4, square root 2 over 2. Plus sine of 5 pi over 3, that's going to be negative square root 3 over 2. Sine of pi over 4, square root 2 over 2. Now we do our algebra. 1 times root 2 is root 2 on top. 2 times 2 on the bottom is 4. Notice here we have a negative times a positive. This is going to be negative. Root 3 times root 2, that's root 6. 2 times 2 on the bottom, that's 4. Common denominator 4, so we could write it instead as root 2 minus root 6 over 4. All right, number 3. Number 3, the purpose of number 3 is mathematic is trying to show you where the double angle formulas came from, okay? So number 3 shows you where the double angle formula for sine comes from. And one of the homework problems shows you where the double angle formula for cosine comes from. So let's go ahead and let's derive this formula that I gave you up above. So first it says, can you rewrite the double angle 2 theta as the sum of two angles? Sure we can. 2 theta is the same thing as theta plus theta. So now, let's take sine of 2 theta. Let's write it as sine of theta plus theta. So we're taking 2 theta and we're representing it as a sum. This means that for the formulas up above, the addition formula for sine, both alpha and beta would be theta. So following the addition formula, sine of alpha plus beta, this would be sine of alpha, so sine of theta, times cosine of beta, cosine of theta, plus sine of beta, which would be sine of theta again, times cosine of alpha, but alpha is theta, so cosine of theta again. There are two of these. This is sine alpha, this is sine theta cosine theta. This is sine theta cosine theta. If we add them together, there's two of them. 2 sine theta cosine theta, which is exactly the formula we wrote up above. So this was there to kind of show you where that comes from. Those double angle formulas actually are derived from the addition and subtraction formulas. All right, number 4. Solve the equation sine of 2x minus sine of x equals 0. Okay. All right, sine of 2x, well, we literally just derived the formula for it. Sine of 2 theta is 2 sine theta cosine theta, so sine of 2x is 2 sine x cosine x. Then we drop down our minus sine x equals 0. All right, notice now that both terms have a sign in common that can be factored out. Let's factor out the sign. If I factor sine out from 2 sine x cosine x, we just get 2 cosine x. If I factor sine out from negative sine, I get negative 1. Now, take these two factors, separate them individually. Sine of x equals 0. 2 cosine x minus 1 equals 0. Sine of x is equal to 0 when x is 0, pi, and 2 pi. Right here, we would add the 1 over and then divide by 2. So this is saying cosine of x equals 1/2, and cosine of x equals 1/2 when x is pi over 3 and 5 pi over 3. So our answers, x is equal, let's take all 5 of those angles, 0, pi over 3, I'm going to put them in order, pi, 5 pi over 3, and 2 pi. All right, y'all, that's been the 7.6 notes. I'm also going to make a video going over the homework solutions as well for 7.6. Have a great day, y'all.